we're looking at notes LL-2 rationals, and we're looking at oblique or slant asymptotes. So a rational function in the form f of x over g of x has an oblique asymptote when the degree of f of x, or in other words the numerator, is greater than the degree of g of x, or in other words the denominator. So combine all horizontal and slant asymptotes and call them EBA, or end behavior asymptotes. So not including the vertical asymptotes because those won't affect end behavior. Okay, so just the horizontal and slant asymptotes because they will affect the left and right end behavior. Leftmost and rightmost end behavior, excuse me. So find the EBA. Does the graph cross the EBA? So let's look at equation number 1. So look at the degrees of the numerator, look at the degrees of the denominator. Certainly the degrees of the numerator is larger than the degrees of the denominator. So if that's the case, where the degree of the numerator is greater than the degree of the denominator, then we are going to actually divide. So we are going to take the numerator, 2x squared minus 3x minus 9, and divide it by the denominator. So the denominator is the divisor, and the numerator is the dividend. Okay, so long division, you would take 2x squared divided by x, and you would get 2x. So line it up correctly, and then multiply back in, so 2x squared. So then, of course, when you subtract, all right, that turns to 0. So then you're going to drag down the negative 3x and the negative 9. So then negative 3x divided by x is negative 3. So then negative 3 times x is negative 3x. Then, of course, you subtract. So when you subtract, that changes the sign. So then you would have 0, of course, so drag down the negative 9, but you are going to ignore this. This is the remainder. You ignore the remainder. Okay, you can't divide, well, I mean, negative 9 divided by x, it's not going to divide to where you can put something up here. So you're not going to be able to divide. Negative 9 divided by x, negative 9 would be the remainder. So you ignore that, and your oblique asymptote will be oblique, and it's y equals 2x minus 3. So I'm going to box this up, and you always need to classify, meaning don't just put an equation for the end behavior asymptote. Classify whether or not you're dealing with an oblique asymptote or a horizontal asymptote. Okay, so now let's test if the graph crosses the oblique asymptote. Okay, so remember, take the EBA, the end behavior asymptote, and set it equal to the function. So we have 2x minus 3 equals 2x squared minus 3x minus 9 over x. So then I'm going to put the left side over 1, cross multiply. So of course x will distribute into both terms here. So 2x squared minus 3x equals 1 times all 3 terms on the right. All 3 terms in the numerator of the right side stay the same. Okay, and then the nice thing is the 2x squared and the 2x squared eliminate. The negative 3x and the negative 3x eliminate. So on the left you have 0 equals negative 9. And of course that's not a true statement. So our answer here for crosses EBA would be no, does not. Okay, next example. So again, our numerator, the degree of our numerator is larger than the degree of the denominator. So we know we're going to have an oblique asymptote. We need to find the equation. So you will take x plus 2 as your divisor, and then the x squared minus 4x plus 3 is your dividend. And then x squared divided by x is going to give you x. I'm going to line it up, so distribute that x into both terms of the divisor. So x squared plus 2x. Remember that you are subtracting, so this becomes minus, this becomes minus. Okay, so obviously that crosses. And then here we get negative 6x, drag down the plus 3. So then negative 6x divided by x is negative 6, lining up. Distribute that term into both terms of the divisor. So negative 6x minus 12. And again, you're subtracting, so you want to change signs on both terms. And so that's 0. I'm not going to write anything. And then a positive 3 and a positive 12 would be 15. Not that I really care, because remember, the remainder you ignore. You ignore the remainder, okay? So as long as you've drawn out all terms all the way to the constant term here, once you've filled up this last space, you're not going to go any further, okay? So ignore our oblique equation. Our oblique asymptote is y equals x minus 6. Okay, so does this graph, when drawn, cross through the oblique asymptote? So EBA equals f of x, remember? So x minus 6 equals x squared minus 4x plus 3 over x plus 2. So then over 1 and cross multiply. So here we are going to have to FOIL, because we're going to multiply x minus 6 times x plus 2. So that's going to give us x squared. It'll give us minus 4x when you FOIL, and then negative 12 equals, of course, this term times all three of these. All three terms in the numerator will remain the same. Our x squareds will simplify out. Our negative 4x will simplify out. And negative 12 is certainly not equal to 3. So the answer to this question is no. We do not cross through the oblique asymptote. Last example of this type. So again, numerator, degree of numerator is 3, degree of denominator is 2. So we have an oblique asymptote. I'm classifying first. And then I am actually x squared minus 1, taking that divisor, the denominator, and putting the numerator x cubed plus 0x squared plus 0x plus 0. Okay, so x cubed divided by x squared would be x. And so distribute into both terms, so I'd get x cubed minus x. So then I'm going to subtract, so minus, plus, change signs on both. The 0x squared, no reason to drag it down because you don't want a 0 in front. That's 0, that's 0. This becomes x plus 0. But then what happens is you're going to ignore this. This is called your remainder. Here's why. X divided by x squared would give us a remainder, something in the denominator. Okay, so once the degree drops below the divisor's degree, we can stop. So that's kind of like what I was talking about here. Now, I know we still have room to go, but once this degree is less than the divisors, we're done. Okay, so bubble this up. Okay, so then our oblique asymptote is y equals x. And does the graph cross the oblique asymptote? All right, so crosses EBA. I need to change pens. EBA equal f of x. So x equal to x cubed over x squared minus 1. So this numerator distributes into both terms of the denominator, so that would look like x cubed minus x equals, and then x cubed, and then here the x cubes simplify out, so negative x equals 0, divide both sides by 1, so x equals 0. So yes, we finally have a graph that crosses through the asymptote. So the x value of that cross point is 0. Okay, we got that from over here. And then the y value comes from plug x into the EBA equation. Okay, so if I plug in x to the EBA equation into y equals x, of course my output is going to be 0. So 0, 0, the origin is the point where this graph crosses through its oblique asymptote. Okay, so now we're going to practice with some graphs. All right, so model the assignment. Find the roots, find the vertical asymptotes or totes, find all end behavior asymptotes, find the y-intercept. Does the function cross its end behavior asymptote? If so, where? And graph the function. Okay, so first of all, let's remember to find the roots. You set the numerator equal to 0. Okay, so what you first want to look for is factoring the numerator. So there are no such values that multiply to 8, but add to positive 4. So this is not factorable. However, remember, you don't know for sure if there's irrational roots. Not factorable tells us there's no rational roots, okay? But it doesn't tell us that the roots are imaginary. They could be irrational. Would I probably have you graph that? No. But is it a possibility at some point in your lifetime? Sure, of course. So you should always really check with quadratic formula. If you're dealing with a quadratic here, remember the, not the opposite of b, I'm trying to do quadratic formula here. Just the discriminant, b squared minus 4ac. If you take b squared, which would be 16 because b is 4, minus 4 times a is 1 times c is 8, think about that value. 16 minus 32. I don't really care what the value is, but the fact of the matter is that it's going to be a negative value, and that tells me imaginary roots, so definitely I don't cross through the x-axis at all. So that answers the question of roots is none. Wasn't factorable. There were no like binomials that I could set equal to 0. So I have no roots. VA is when the denominator is set equal to 0. Well, 4x equals 0 would produce x equals 0. Of course, if you divide both sides by 4. So x equals 0 is my vertical asymptote. I think I'm going to draw as I'm going here. So x equals 0 is my vertical asymptote. Kind of draw off the graph so you can see that it goes off the graph. And then end behavior asymptotes, so that's our horizontal or our oblique. That's hard to say that a couple times fast. So the numerator degree is definitely greater than the denominator. So that indicates that oblique asymptote. Remember, if it was a horizontal, let's say like HA or horizontal asymptote to classify. So oblique asymptote, so I'm going to take 4x on the outside, divide by x squared plus 4x plus 8. Okay, so x squared divided by 4x. Well, that's kind of a tricky one from what we've done so far. X squared divided by 4x. Of course, an x there will simplify with an x here. So that'll give us x over 4, or in other words, 1/4 x. So 1/4 x times 4x surely would give us back to x squared. So then, of course, you subtract. Okay, so drag down the 4x and the plus 8. So now 4x divided by 4x is 1. Okay, and you can tell you're definitely finished here because we line up with that constant term. So 1 times 4x is 4x. You subtract. And 8 is your remainder, but remember, we ignore that sucker. So ignore. Our oblique asymptote is y equals 1/4 x plus 1. Okay, 1/4 x plus 1, so 1 is my y-intercept, and then 1/4, so up 1, right 1, 2, 3, 4. I'm just lightly marking up 1, 1, 2, 3, 4. So down 1, 1, 2, 3, 4. 1, 2, 3, 4. Did I get 1, 2, 3, 4? Yeah, okay, I'm good. And then, of course, you know an asymptote is indicated with a dashed line, so I'm going to draw a nice dashed line there. Okay, so now I've got that y-intercept x equals 0. I want you to think about this. If I have this function here, and I plug in 0 everywhere I see x, that's 0, that's 0, that term 0, that term 0, that term 0. The only thing I have is y equals 8 in the numerator over 0 in the denominator. Remember, 0 in the denominator means undefined. Okay, so therefore you are going to have none y-intercepts. No y-intercepts. Okay, and that makes sense because, hello, you have an asymptote on x equals 0. Okay, so no y-intercepts. Do we cross the end behavior asymptote? Do we cross the oblique asymptote? So remember, EBA, I keep getting this wrong. EBA equals f of x. So in other words, 1/4 x plus 1 equals x squared, you'll have to look up at your top, x squared plus 4x plus 8 over 4x. Okay, so you're going to put this over 1. I know that fraction in a fraction will live. Okay, you're going to distribute this term to both terms of the numerator. So you would get, we're going to go ahead and just, let's make this a little bit easier. That way you can see. And then on the right, okay, so like I said, the 4x distributes to both terms here. So 4x times 1/4 x is x squared plus 4x. 4x times 1 equals x squared plus 4x plus 8. And look at here. Cross, 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 cross. And does 0 equal 8? Certainly not. So do we cross the end behavior asymptote? The answer is no. All right, so then we can start looking at our graph. So let's remember that we have no roots. We have no roots, and if we have to hug these asymptotes here on the end, that means that this graph must have a curve on this side and must have a curve on this side, because we couldn't have a curve on this side because we would have to cut through here on the x-axis to hug, and same here. If we hugged this way, we would have to cut through the x-axis. So that tells us that the curves must be in these spaces.